Hello everyone and welcome back to Life Technologies YouTube channel. I hope you're doing well and thank you so much for watching this session. So this is another episode of our Juniper Lab simulations. Remember, we have a series that demonstrates to you how to configure and implement different networking protocols or different networking technologies on Juniper routing and switching devices. So if you are learning how to manage and operate Juniper devices, kindly check out this series on our channel. And just a kind reminder that if you are watching this video and you are yet to subscribe to our channel, kindly support us by subscribing to this channel. Also remember to like, comment and share this video with your connections. So in this lab, we are focusing on how to implement basic ISIS configuration on Juniper MX routers. So ISIS is one of the protocol that is commonly deployed on production network. Remember, ISIS is an interior gateway protocol, so you can deploy it within an autonomous system and it will ensure that you have reachability between different devices. So when you are managing especially service provider networks, this is one of the protocol that you really need to master. You need to know how to configure, how to troubleshoot, and how to verify ISIS protocol on Juniper routing and switching devices. So this is the topology that we are using. You can see that we have three devices. We have R1, R2, and R3, and they are all connected, and we are configuring them in an ISIS process. So we've assigned different IPs. You can see that the loopback IP for router 1 is 1.1.1.1. For router 2 will be 1.1.1.2 and router 3 will be .3. And then we have the point-to-point IPs configured or assigned between the different routers. Between R1 and R2, we have 10.10.10.0/31. So we'll be configuring .0 on R1 and .1 on R2. And then between R2 and R3, we have 10.10.10.2. So we'll be configuring .2 on R2 and .3 on R3. And then we'll move ahead and do the other configurations. So one of the basic things that you need to do when you are starting these Juniper routers on the EVNG is you need to configure the root authentication password. So that has already been done. And then you need to go ahead and configure the host names. Remember, it's always a good practice to configure host name on the devices so that when you log into the device, you know which device it is. And then we'll go ahead and do interface configuration. So we can do interface descriptions, we can assign IP addresses, and then once we've done that, we can go ahead and now implement ISIS protocol on these devices. So I've logged into the devices on Secure CRT. Let me try to make it side by side so that we are able to see the topology. So with these devices, the first thing I've mentioned that we need to configure the host name. So I will configure host name on all the devices. And remember, when you are doing the configuration, you always have to commit. So once you do the commit, the configurations will now become active, and you will see that the host name will change to R1. So remember, normally on Juniper, we use the set command first. If you are not in the configuration view, you need to configure, and then you can now start configuring the different parameter that you want. So I'll do set system, and then you specify host name. This will be R1. Many times we use this command to see what we want to commit on the devices. So you are comparing the candidate configuration that you've applied. So when you run show pipe compare, you can see that we are adding a host name, which is R1. So you can do commit. Once you commit, you see that the host name will change to R1. So it takes some time to commit. You can see now that our router, the host name has changed to R1. Can do the same on R2 quickly. Set system host name, set it to R2. As usual, you do show pipe compare, and then you commit. You expect it to change the host name to R2. Set system host name. This will be R3, and then I commit. Sometimes you can do a commit check just to ensure that you've used the correct syntax, especially in a production environment. You can do a commit check, which help you to check the syntax that you've used to avoid issues when you are now deploying the configuration during the maintenance window. So you can see that we've changed the host names to the respective correct names for the devices. So the first thing that I need to do is to configure the interfaces. So in our previous session, we've already demonstrated to you how to configure the interface parameters like the IP address. You can also configure the description. So I'll start by configuring interface gig 000 on R1. So I'll set interfaces G 0/0/0. I can give it a description. I just say to R2. And then I need to configure an IP address. So I'll do set interfaces. Can just recall the same command, clear this. And then I'll do unit 0. Family, remember we need to specify the family as inet because this is IPv4. You can check the other parameter that you have, and then I'll assign it an IP address of 10.10.10.0. mask is 31. Can also do the loopback configuration. So I'll set interfaces loopback 0, unit 0, family it's inet, and then I'll give it an address of, this is 1.1.1.1, mask is 32. So I can do show pipe compare to check the configurations. So you can see that we are configuring description on GE00. You have an IP address. Also for the loopback interface, we have an address assigned. So I say that sometimes we can do a commit check to check whether we have the correct syntax. So you can see that the configuration check succeeds, and then I can go ahead and do now a commit so that we have an IP address assigned on the interfaces. We also have the description assigned on the interfaces. So on R2, we need to do the same. So I'll do set interfaces G 0/0/0 unit 0. I give it a description. This will be 2. This is connecting to R1. Then I'll recall the same command using the upper arrow, and I do family inet. Once I do family inet, I can assign an IP address of 10.10.10.1, mask is 31, and I go ahead to do the configuration on, so set interfaces loopback 0, unit 0, I do family inet, and then I'll assign an IP address of 1.1.1, mask is, this should be .2, mask is 32. So you need to check the parameter that you are configuring just to verify that they are the correct ones. So if I do show pipe compare, you can see same parameters on GE00 and then on loopback 0. So I can do commit check. Then I do commit confirm. Now this one I just do commit. Commit confirm is when you want to, maybe you want to commit for some few minutes. Maybe you are not sure with your implementation and you want to test whether the configurations are okay or whether the impact, there will be no impact on the network. So you can do commit confirm and you specify the period of time, maybe 5 minutes or 2 minutes, sometimes even 10 minutes, depending on the scenario that you are working on. So the next interface that we need to configure is on G001. So set interfaces G001. And then we need to give it a description. So unit 0, description, this one will be to R3. I recall the same command and enable family inet and assign an IP address of 10.10.10.2, mask is 31. So if I do show pipe compare again, you can see that these are the parameters. I do commit. And then we need to configure R3. So for R3, try to move this one on the left. You can see that the IP address is 10.10. This one will be 2.2.3. Then this one will be 1.1.1.3 for the loopback interface. So I'll do those configurations on R3. So I'll set interfaces GE 0/0/0 unit 0 description. It's to R2. And then I'll recall the same command and assign an IP address. So family inet address will be 10.10.10.3, mask is 31. We'll set interfaces loopback 0, unit 0, family inet, and then I can go ahead and assign the IP address of 1.1.1.3. Mask is 32. So if I do show pipe compare, these are the configuration that we've configured. I'll commit. So we have completed the basic configurations, and the next step is to now configure ISIS. So when you are configuring ISIS, depending on the type of device, sometimes maybe the router is not enabled to process ISIS packets, or maybe it has been configured to drop ISIS packets, so you may need to enable the family ISO mode. And I mean globally on the routing security forwarding options of the router. But if it's not, then you need to just go ahead and configure ISIS parameters. So for us to configure ISIS, first on the family, we need to enable the family ISO on the interfaces. So starting with R1, again, this is R1. I'll go ahead and set interfaces. We started with GE00, then it was unit 0. It can do family ISO to enable ISIS on that interface. And then remember, once we've done this, we also need to enable ISIS on the loopback interface and configure the network entity. And how do we generate the network entity? Many times, remember, we have the area, and then we have the system ID that is generated from the loopback IP. We've discussed this in our previous sessions, even on Huawei routing and switching devices. So you can just revisit and learn how you generate the network entity from the loopback IP. It's very straightforward. So I'll set interfaces loopback 0. This is unit 0. Then family inet. No, remember we've already enabled family inet. So this is ISO. And then we need to configure the address. So this was area 10. So I'll do 49.0010. Then we need to append the entity, the network entity or the system ID. So remember this one is 00. The loopback IP is 1.1.1.1.1. So we need to have 0.0.1.0. This one should be 0. And then remember we still have other ones that are pending. So how we generate these, maybe if I just demonstrate to you quickly, we have 1, 1, 1, 1. So we need to make it 3, 3, and then 3, 3, 3, 3, 3, 3, and then we split it into 4. So when we split it into 4, we have 0, 0, 1, 0. Then this one will be 0, 1, 0, 0, then 1, 0, 0. And remember at the end, we normally have the selector, which is 0, 0. That is it. And then now we can activate ISIS, set protocols, ISIS. Then we do interface GE00 0/0/0. And then we also set protocols. I can just recall the same command, interface loopback 0.0. So if I do show pipe compare, you can see that we've configured the network entity. We've enabled family ISO on both loopback and the physical interface, and then we've activated protocol ISIS, and we've enabled ISIS on the two interfaces, interface GE00 and interface loopback 0. So we'll do the same on R2. So on R2, we need to do the same. So the first thing is to enable ISO on the interfaces. So I'll set interfaces G00 unit 0 family ISO. Then remember we have G001. Then we have the loopback. So this one will be loopback 0 unit 0. And then we need to configure the network entity. So it's family ISO. Then the address 49.0.010.1001.1001.00. That will be the network entity. And then we do set protocols, SIS interface GE 0/0/0. We have GE001. Actually, we need to do this one should be .0. Remember, it's on the family, on the unit, that is. And then we also need to do loopback 0.0. So if I do show pipe compare, we expect to see the configurations. If I do commit check, so the configuration succeeds on this router. I'll also do commit check and then commit. On R2, I will also commit. But you realize one thing, that we've configured the same address for the same address network entity for the two routers. This one we need to make it 2. So these are things that you really need to pay attention to. So now if I commit, and then we'll do the configurations on R3. So set interfaces G00 unit 0, family will be ISO, and then I do set interfaces loopback 0 unit 0 family ISO, and we go ahead and do the address, which is 49.0010.0100 .0100.1003.00, the selector, and then we set protocols SIS interface GE 0/0/0.0, and then set protocols SIS interface loopback 0.0. If I do show pipe compare, these are the commands, and then I commit. So we've completed the configuration for ISIS. Now the next step is we need to do the verification. So on R1, I can now quit the configuration mode and show ISIS adjacency. We don't have any ISIS adjacency. Quit. Show ISIS adjacency. You can see that here we have two ISIS adjacency, and the adjacencies are on. Let's check on R3. Quit. show ISIS adjacency. We have two adjacencies here. On R1, show ISIS adjacency. We don't have, so if I show configuration and then display set, let's check the configurations on this router. So you can see that we've configured G00 unit 0 family ISO, and then we have set interfaces loopback 0 unit family. Also we've assigned the correct parameters. If you check on this router, so you see that the configurations are okay. If I try to ping the point to 10.1, you can see that the ping is going through, no problem. So let's check on R2, show ISIS interface. You can see that we have these two. So we have an adjacency level 1 and level 2. And then we have these two interfaces. Let's check on R1, show ISIS interface. We have the correct parameters. Let's again check on R2, show configuration, display set, match. We just do display set. We don't have a lot of configurations. So you can see that on these set interfaces, that is okay. We've configured /31. We've enabled family ISO on the interfaces. And then we have configured. So on this router, you can see that we have two families. So that is the problem, because the other one did not. So I need to delete. This is how you delete a configuration on Juniper. So just instead of set, you delete. So remember, we had this network entity set. And whenever you have a duplicate network entity, then ISIS will not establish. So if I show, I don't know whether we have ISIS statistics. We can troubleshoot in the next scenarios, in the next episodes. But what I need to do is I need to delete this one and show pipe compare, commit. Then we expect, because we had a duplicate network entity, so the ISIS adjacency will not establish. So when I go back to R1 and show ISIS interface, that is okay. Show ISIS adjacency, you can see that we have two ISIS adjacencies, one in level 1 and another one in level 2. So you can specify, maybe you just want to have level 2. You can also go ahead and specify the levels that you want these routers to establish an adjacency in. So when I do show ISIS adjacency, you can see that on this router, given that it's connecting to two other routers, so we have four adjacencies: 2 towards R1, level 1 and level 2, and 2 towards R3, level 1 and level 2. And then on R3, if I show ISIS adjacency, we have the same scenario. So you can see that on this router, let's see, we have on R1, R2, of course, we don't want to establish an adjacency with the other router, but we need only to establish an adjacency with R2, because those are the adjacent routers. So this is how you implement. You can show routes, protocol ISIS, and you should be able to see the ISIS routes. On R1, you can do the same. Show route ISIS, show route protocol ISIS. You see the route that we've learned through ISIS. Am I able to ping the other side, 1.1.3? See, we can be able to ping from R1 to R3. So for the configurations, again, if I show configuration, display set, you see that it's very easy to implement ISIS on Juniper routing devices. You can see that you need to enable family ISO. Of course, you start by configuring IP addresses on the interfaces. You need to enable family ISO for these routers to be able to process the ISIS packets. And then you need to configure the network entity. And this one we generated from the system management interface, so the LUBAC 0 interface. And then you need to enable ISIS on the interfaces. So this is a very straightforward implementation, just basic ISIS configurations, and we'll be doing more advanced features, maybe multi-level, multi-area ISIS, just to help you to understand how you can implement ISIS on Juniper routing devices. So I hope you've enjoyed this session. I hope you've learned something, and I hope to see you in the next session. Just a kind reminder again that if you have watched this video and you are yet to subscribe to our channel, kindly hit that subscribe button and stay tuned in for more upcoming sessions. Also remember to like, comment, and share with your connections. Thank you so much and see you in the next session. Bye.